Hello guys, my name is Alexio. I'm going to be showing guys how to code your robot. So the very first thing when we quote unquote code a robot, we need to first learn how to move a motor. So this video is going to show you guys how to move a motor. And the very first step to do that is you need to have this software. So this is the VexCode Pro V5. This is the software that you need to download first. And then once you have downloaded, come back and watch this video. So to get started, you're going to go to the top left and you're going to click File, right? And then you're going to say New. And then you're going to name your project. It's going to be your name. And then today's year or this year's year. So boom. Once you're done, once you press Enter, your screen should now look like this. So it may look confusing, but I'm going to walk you through it. So the main thing that we're going to focus on is this right here. This is basically the text editor. This is where we're going to do our code. And at the very left, you see this column. This is not that important. Majority of the time, you're going to ignore it. And at the top, you see the tabs. These are just tabs. But right now, we're going to mainly focus here. So before we start, you need to first set up your electronic. So you're going to get your brain and do all of that stuff and set it up. So this is your Vex box. It's going to have all the supplies you're going to need for this. You're not going to need everything, but only a select few items. You're going to need your controller, your battery, your brain with your Vex receiver, a motor, the wires, and your micro USB cable. Once you have taken the supplies, you're going to grab one of the wires and you're going to plug it in into port 1 of the brain. The next step is you're going to grab that other end of that wire and you're going to plug it in into a motor. So the motor is successfully connected to the brain if the motor is emitting a red light. So the next step is you're going to grab the Vex receiver and you're going to plug one of the wires into that receiver. And then you're going to grab the other end of that wire and you're going to plug it in to port 21. Port 21 is located in the end of the brain. And you know the connection is secure and good if the receiver is emitting a red light. The next step is you're going to grab the micro USB cable and plug it into your computer. And then finally, plug it in to your brain. Now, once you have set up all your stuff, now you're going to go back to your computer. And then once you plugged in your motors, your controller, your batteries, everything to the brain, you need to tell the brain, hey, you know what? We're going to, these electronics are connected to the brain. In order to tell your brain that these items are connected to it, you're going to go here to the top right. So there's going to be this cable looking thing at the top right. You're going to click on it. And basically, this is the robot configuration. And then you're going to click Add Device. And then once you click on Add Device, now you need to select the device. So in this case, I'm going to show you guys how to do with a motor. So we're going to click Motor. And then we're going to click number 1. So in your brain, you should see that there's these ports, right? There's these holes and they're labeled 1 through 21. So your motor should be plugged into port 1. If you do not do that, it's not going to work. So make sure your motor is plugged into port 1. So you're going to click 1 right here, and then you're just going to click Done. What this does, it's going to generate code for us, one line of code that's going to tell our brain, hey, there's a motor in the system. So you're going to click Robot Config, right? It's going to be in your column. You're going to click on it, and then you're going to see this line of code right here. So this is the code that basically tells our brain, hey, there's a motor, right? There's a motor. The name is motor 1. And then it's in port 1. The motor has a gear ratio of 18:1. And it's also false. So basically, this means reverse direction. So if I click motor 1, you're going to see reverse, right? Normal. So if I click reverse, that's going to go to true. But in our scenario, we're going to keep it normal. So that's basically all what you need to do. So we're going to go back to me. So what I'm going to show you guys is a function that allows us to move that motor. So this function comes from here. So this is a library. This library gives us functions that we can use to move the motor. And that also goes for sensor. This function creates functions that can move motors as also get sensor data. Our goal as a programmer is to create logic for the robot so it can navigate around the field as well as have human inputs control the robot. So that's our goal as the programmer. So the first step we're going to do is, first of all, move a motor. And that's a very simple thing to do. So it's just one line of code. And to start that line of code, right, the syntax is we're going to type down M or the name of the motor. So in this case, it's motor 1. So we're going to do motor 1. So motor 1. And then once you have the name of the motor, you're going to press period. Once you press period, a whole list of options would appear. This is basically syntax of all the different types of things you can do with the motor. You can set its current. Pretty sure this one doesn't, say its current, but actually tells you what the current is. But the thing that we're going to focus on is spin right here. So we're going to say spin. And then if you see here, it gives us basically some guidelines how the syntax for the task that we're going to do. So right now we're on simple. If I do enable X for autocomplete, it'll give us more options, but it's going to be extremely more difficult, right, to code. But you don't have to have this on to basically have access to all the different options. I usually keep it off just because for me it's not really necessary and it just clutters my screen. So I'll give you an example what happens if you click it. So I'm gonna click enable X for autocomplete, and then if I do this, more options are given to me. So you can set the direction type, double velocity, and the percent units. If I unclick it, the options is reduced. But I prefer it this way just because I'm already familiar with it. But if you want to get familiar with this library and all the different types of functions that it has, I recommend having enable X for autocomplete on. But that's after you get familiar with its different types of functions. So right now, I'm going to keep it off for the sake of the video. So once you got that done, I want to press backspace. So basically, the options appear again. So we're going to click the first one, spin direction. So once that, it should also tell me to go forward, reverse. So we want the motor to spin forward. And then that tells us, hey, our motor should spin forward, right? It gives it a direction. And then we're going to do comma. And then we're going to give it a number. So this case, I'll do 200. And this 200 correlates with a unit value, which is RPM. And then semicolon to make motor 1 spin out of forward direction at 200 RPM. So that's what this line of code does. So that's basically it. This is how we move a motor. So I'm going to click download. And I'm going to click run. So you know the download is complete if it says right here. So I'm going to click run right now. And look what happens. So right now the motor should be spinning right now. And it should be spinning relatively fast because it's spinning at 200 RPM. Now I'm going to reduce this value to 100. So I'm click download again. So every time you make a change, you need to press download. So when you press download, it also saves your code and compiles it. So it's a pretty good way to compile and save your code. So I'm going to click run again. Now your motor should be spinning at 100 RPM. So it should spin slower. So I'm going to press stop. So if you're not familiar, this is download your code, run your code, and then stop your code. So once you're done with that, that's how we spin it. But then here we just tell it to spin at a velocity. We give it a RPM. So what happens if we want to be more precise? We basically know how to move a motor at a certain velocity or RPM. Now we need to tell the motor, hey, let's go spin at 360 degrees. And that's very simple. So we're going to go here, right? And we're going to generate this new line of code, right? So we don't want this code to interfere with our new line of code. So we're going to turn it into a comment. If you do not know what comments are, Comments are basically lines of code that's not going to be used. So it doesn't really interfere with the rest of your code. So that basically means it's ambiguous. It doesn't matter. So it's usually allows you to write stuff down in your code without actually interfering it. And to know if it's a comment, the text should be green, like here, and write this, and then also like this. So this new line of code that we're going to write down basically allows us to move a motor at a specific degree. And what I mean by that, it allows, hey, let's go make the motor spin 360 degrees. And that's what we're going to do. So we're going to say motor dot spin. But instead of just spin, we're going to say spin 4. Spin 4. And we're going to do parentheses, the direction, a value, this case 360. And then we're going to do its unit, so 360 degrees. And then end off with a semicolon. So I'm going to click download. And then I'm going to press run. Look what happens. The robot should be spinning. Should spin at 360 degrees. It's going to be fairly fast. So what happens if you wanted to make that slower? We want to make it spin 360 degrees, but slower. That is fairly easy. To achieve that, we're going to go here and we're going to enable export autocomplete. It shows us more options. These options, on or off, this check mark, we'll still have access to it. So that line of code, regardless if this is enabled or not, should still run. But this will just basically give us an autocomplete. So we're going to do motor, and then we'll say spin 4, right? Spin 4, right? And look, if you can see, direction type, rotation, and then whatever the last one is. But the most important one is this. Spin 4, double rotation, rotation units, and double what? Double velocity. This is double velocity. So I'm going to click this. So basically this is the syntax to make it spin degree with a certain velocity. Rotation units, it's going to be degrees. And then velocity, we're going to say 10. And then velocity units, RPM. Write that. So as you can see, there's no we no longer need to say forward. The reason why we do not need to say forward is because 10 RPM, it's basically gives us a direction already. In these two cases, we have to give it a direction, but since this is positive, since we have degrees and the speed technically, that basically gives us a direction already. So no need to declare a direction. So I'm going to turn this line of code to a comment. Now look what happens if we run the code. So I'm going to first download the code, and then I'm going to run. So right now, you should see the program. It's going to basically run the code, and then you should see the motor is spinning very slowly, 360 degrees. We can also change the value and make it spin faster. So I'm going to change it to 100 RPM, like this. And now look, it's spinning a lot faster. And then since I made it faster, I'm going to also increase, make it spin 10 times around. Now watch, I'm going to spin 10 times. Pretty cool. So that's basically how we move the motor. So I'm going to delete everything here. So now we're going to focus on how to move a motor with a human input. We achieve that with the Vex controller. What we want is when we press a button, that action of pressing a button, it moves the motor. So in order to do that, we have to make an if statement. So since we're now including a controller into the system, we have to tell, the brain, hey, look, we're using a controller. So same thing, make sure you're in robot configuration, and you can click add device. And you can, this time instead of clicking motor, you can say controller. Boom, just like that. And then click done. So now you have a controller. Easy. Anytime human input is required in programming, that line of code must be in a while loop. The reason why is we're going to write a piece of code that's constantly checking a sensor. In this case, it's a button. So the button on the controller, it needs to constantly be checking that state. So when that state changes, we can associate that, hey, the button's been pressed. And since we can detect now the button's been pressed, put some logic in. So when we press the button, it moves the motor. If you're confused, it's actually very simple. And that's basically done with an if statement, right? So we already included a controller into the system. The next step is getting the sensor value of that controller. In this case, we're going to use button A. So same thing, we're going to say controller, and then we're going to do period. And then it gives us all these options, all the sensors in the controller. We're going to focus on button A, and then period again. And then here, we're going to say pressing. So the state of the controller, it's a bool function. So this is a bool. This function returns a true or false. And how can we use this to move a motor? So copy and paste this line of code because we're going to use it. And we're going to create a while, a loop. So we're going to do while and a parentheses. And inside those parentheses is true because we want this to constantly loop, and create two brackets. And then inside it, we're going to put an if statement. If statement. And then we're going to paste in our pressing, and we'll make sure get rid of that semicolon. And then again, more brackets, right, for the if statement, right? So I'm just going to make it look a bit more neat, right? So whatever code is between these two brackets, it's going to be executed. So in here, we want to put down the code for moving a motor. So if you don't remember, just if you get confused anytime, just remember the name of the motor, just write it down, and then press period. And all the options come up. So again, right now it looks kind of messy. Remember to enable expert autocomplete, disable it, so it becomes less messy. And then we're going to do spin, and then we're going to do forward 100 RPM. And then, but there's one problem with this line of code. So once we press button A, there's nothing telling the motor to basically stop. So it's going to continuously spin forever. So to fix that, we're going to create an else. And then in that else, we're going to do motor 1 dot, and we're going to do spin, and then parentheses, forward 0 RPM. Okay, so by stating the motor, right, velocity or RPM to 0, it basically stops the motor. So since we associate with the else in the if statement, whenever the button is not being pressed, the code is telling the motor to stop, have a RPM of 0. So when we do press the button, it starts spinning. So when we let go, it stops spinning. So we're going to press download, and then we're going to click run. Now look what happens. I'm going to press the button, and I'm going to let go. Right? The motor is now associated with an action, in human input. So that's how we move a quote unquote motor with a button. And then this is very useful, right? This goes for any aspect where the robot requires a movement. In this case, like the intake requires a motor to spin a wheel, which sucks stuff in. So this line of code is very good for an intake. But what happens if you want to control a motor with a joystick? A very similar concept. The only difference is we're going to use a variable that's changing, and that change is going to then change the motor's velocity, aka its RPM. But it's very simple. So I'm going to erase everything here, this if statement. I'm going to erase it. Now we're going to use the controller joysticks. So if you look at the controller should have these numbers like 1, 2, 3, 4. that number is associated with the joystick axis. For example, 3 is associated with the left joysticks up and down. That up and down movement correlates to a value between 100 to negative 100. So when I pull the joystick down, it's going to give me a value of a negative 100. If I push the joystick up, it's going to give me a value of 100. These are whole number values. So they're integer, right? It's an integer. And since this value, this variable is changing with the position of the joystick between negative 100 to 100, we can use that value to move a motor, and it's very simple. So the first thing what we have to do is we're going to create a variable, integer, right? And we're going to call it AX3, representing axis 3. We're going to set that equal to controller, period, axis 3, period, position, percent, and semicolon, right? Axis 3, this variable is now associated with the axis 3's position, right? And remember, its range is between negative 100 to 100. Remember, that's the range of the joystick. What we want to do, right, is when we pull the joystick all the way up, we want the motor to spin at its maximum RPM. And then when we pull the joystick down, we want it to spin at maximum RPM, but at the opposite direction. And we basically, it's a combination of this variable and the first line of code we learned. So it's going to be motor, period, spin, give it a direction forward. We're going to give it, instead of doing 100, we're going to assign it with axis 3 or AX3, period, comma, and then instead of doing RPM, we're going to do percent. This percent, imagine it as a throttle. At maximum throttle, the motor will be spinning at its maximum RPM. At negative 100 throttle, it's gonna be spinning at the maximum throttle at the opposite direction. So make sure all the line of code we just wrote is under the while function. Make sure it's all under while. If not, it's not gonna run. Because like what I said before, we need to be constantly checking the state of the sensors of the controller. In this case, we are constantly checking the position of the joystick, as well as we're also be constantly changing the RPM of the motor. If that wasn't on loop, it'll basically just the state of the sensor, and then that's going to be 0 because we haven't moved it. And it's also going to assign the motor's velocity to 0. So nothing would happen. So make sure everything's under while, because we are always constantly changing the motor's velocity, the joystick's position. That's why these two lines of code needs to be in while. If you don't really understand the concept of that, it's okay. Practice means perfect, right? The more you get familiar with this, the more you're going to start associating with the type of logic when it comes to programming a robot. So once that's done, you're going to download this code and you're going to click run. So now I want you guys to grab your controller and move that joystick. Move it up and down. As you can see, depending on where you move the joystick, right, that's also going to move the motor. So I want you guys to pull it up and look what happens. It's a maximum velocity. Now pull it down, maximum velocity, but in the negative direction. So the reason why this is important, because basically this is how we have a robot move. This is how we control a robot during our player controlled portion of the competition. These are very simple lines of code. The reason why this is important, because in simple terms, this is how we move our robot during competition. We have a joystick. That joystick, depending where we move it, right, is going to move our motor. And that movement of that motor is going to then drive our robot forward. make our robot go backwards, make it turn left, and make it turn right. And it's basically up to our skills to develop the logic to make it turn left and right. It's basically up to you, the programmer, and the driver to basically figure out how this should be programmed. How should the robot be controlled? Another important information to know is to debug your code. A very easy way to debug your code is basically have your brain screen change colors depending on a certain action. So that's how I do it. I associate actions with a color. So in order to change the brain screen's color, write down brain, period, screen, period, and then you're going to say set fill color right here. And then in this case, I'm going to say green. And then we're going to do semicolon. And then this sets a fill color, but it doesn't really change the background, right? It only sets a fill color on a shape that we're going to create. So this is what I mean. So I'm going to say brain dot screen dot draw rectangle. So the first two are position of where this rectangle should be, and the next are your width and height. So I'm going to set that 500 so it fills up the whole screen. So basically, this tells our brain, hey, set a fill color to green, and then draw a rectangle at the coordinates of 0, 0, with a height of 500 and with a width of 500. Width or height doesn't really matter. What really matters is it fills up the whole screen. So make sure these two numbers are above 500. And then this should basically, when you click download and run, it should basically change your brain screen to green. You can use more than just green, right? There's blue, there's purple, there's red. Experiment around, try and figure out how much colors that you can set the brain screen to. The reason why changing the color screen is important because it allows us to debug our code. Here's an example. So I'm going to enable export autocomplete again because it's going to help me out. So I'm going to write down motor, and remember spin 4, and then we're going to do the how many degrees it should rotate. In this case, 360 degrees. 360 degrees. And we're going to write down degrees. And then again, we're going to do 100. Oh no, just 10 to make it slow. RPM. So as you can see here, spaces do not matter. This is basically that space. If you have the spaces do not really affect with the syntax. Syntax, again, if you do not know, it's like the grammar of a programming language. So once you have this done, another thing that we're going to add is another comma, and we're going to put down true. Look what happens if you put down true. Look what happens. If it's true, right? Look at the screen. Look what happens. Look at the motor and look at the screen, right? What should happen is the motor is going to spin, then the brain screen is going to turn green. So what you just saw is this line of code, right, is going to prevent everything from executing below it until the motor spins for 360 degrees, right? That's really bad. In some cases, we don't want that, right? We want the motor to spin 360 degrees without affecting the rest of the code, without preventing any line of code executing, right? So see this true, I want to set it to false. Look what happens. So I'm going to click download, and I'm going to click run. Look what happens now, right? The motor, right, it spins, and as it's spinning, the brain screen turns green, right? So this line of code is no longer affecting or preventing any other lines of code to execute. It does this by multitasking. You can multitask functions, so you can have two functions run side by side, This is different from multi-threading. I will talk about that later, right, on another video. The takeaway from this is when you have motor.spin4, if you want to spin to a certain degree the motor without affecting the rest of your code or withholding lines of code to be executed, remember to put comma false because it multitasks that function, right? Set it to true if you wanted to affect the execution of the code below it or withheld the code from executing until it reaches that certain degree. For example, like autonomous. You want the robot to move, 10 inches forward. You can basically use motor.spin to make the robot go forward. So that concludes the end of the video. Your main takeaway should be that coding a robot is not that difficult. Even though it may seem complicated at first, you can split it up into a series of simple tasks, which can be easily done.